Welcome to Educator.com. In today's lesson, we'll be discussing linear functions. A linear equation is an equation of the form ax plus by equals c. And linear equations can actually be put into several forms, but the form that I'm introducing right now is called the standard form. So this is the standard form of a linear equation, where a, b, c are real numbers and a does not equal 0, or b does not equal 0, or both a and b are not equal to 0. What this is saying is that a may be 0, or b may be 0, but they can't both be 0. And if you look at this, it makes sense. So let's substitute in some numbers for a, b, and c. Let's write a linear equation as an example. 4x plus 3y equals 8. So here I have a, b, and c. A equals 4, b equals 3, and c equals 8. It is possible that a can equal 0. So let's let a equal 0. If a equals 0, then what I'm going to end up with is 0x plus 3y equals 8. If the rest of my equation is the same, I still have b equals 3 and c equals 8. Therefore, the x is going to drop out, and I have 3y equals 8. So this is okay because b did not equal 0. Now, another possibility is that b equals 0, but a does not equal 0. So in that case, for this situation, I would still have a equals 4, so 4x, plus this time I'm going to have b equals 0. So it would be 0 times y equals 8. Now my y drops out, and I have 4x equals 8. So I have a situation here where I could have 4x plus 3y equals 8, and then I gave another situation where a was equal to 0, but b was equal to 3, and finally b was equal to 0, but a was equal to 4. What I can't have is a situation where both a and b are 0, because if that were to occur, both my x and y would become 0, and then I would not have a linear equation. The graph of a linear equation is a straight line, so it's linear. For example, a linear equation might look like this. So I have a straight line. The x-intercept is the x-coordinate of the point at which the graph crosses the x-axis. So looking at this graph crosses the x-axis at 3. My coordinate here is going to be 3, 0. In this case, the x-intercept equals 3. So this is the point at which the graph intercepts or intersects with the x-axis. And with the x-intercept, y is always going to equal 0. So y is always going to be 0 at the x-intercept. Looking at the y-intercept. The y-intercept is the y-coordinate of the point at which the graph crosses the y-axis. So here, the graph crosses the y-axis at 3. So my y-intercept is going to be at the point 0, 3. And I'm going to say that my y-intercept also happens to equal 3. Okay. So notice that at the y-intercept, the value for x is 0. At the x-intercept, the value for y was 0. And we're going to talk more about these concepts later on. The graph of a linear equation can actually be found by identifying and plotting the x and y intercepts of the graph. And the reason is you need 2 points to plot a line. And if I find the x-intercept and the y-intercept, I end up with 2 coordinate pairs, so I can plot the line. In order to illustrate this, we're going to use an example, 2x minus 3y equals 6. And this is a linear equation in the standard form, ax plus by equals c. So how do I go about finding the x-intercept? Remember that at the x-intercept, y is going to equal 0. Therefore, if I let y equal 0 and I solve this equation, I can find the x value, and that x value will be the x-intercept. So 2x minus 3, 0 equals 6. So 2x minus 0 equals 6. If I divide both sides by 2 to isolate the x, I'm going to end up with x equals 3. Therefore, this is my x-intercept. So I can go over here and graph it. My x-intercept is going to be at 3. And remember, it's going to be 3, 0. So I have my first point on the graph. Doing the same thing with the y-intercept with the same equation, 2x minus 3y equals 6. At the y-intercept, x is going to equal 0. So if I let x equal 0, I get 2 times 0 minus 3y equals 0. 0 actually equals 6. Correction. So 2x minus 3y equals 6. If I substitute in x equals 0, I'm going to get 2 times 0 minus 3y equals 6. So that's 0 minus 3y equals 6. And that's negative 3y equals 6. Dividing both sides by negative 3, I'm going to get y equals negative 2. So my y-intercept equals negative 2. Therefore, the y-intercept is going to be down here at the point 0, negative 2. Now that I have 2 points, I can graph this equation. So in order to graph this equation, what I did is in order to find the x-intercept, I let y equal 0, and I found that the x-intercept is 3. In order to find the y-intercept, I let x equal 0, and found that the y-intercept is negative 2. That gave me 2 points, and with 2 points, I can plot out my line. A linear function is a function in the form f of x equals mx plus b, where m does not equal 0. The graph of a linear function is a straight line. So sometimes you'll see this as y equals mx plus b. And to give an example to illustrate this, you may have an equation or function f of x equals 2x minus 3. In order to plot this out, what I could do is graph out some coordinate pairs, or I could find the intercepts. So let's make a table and generate some coordinate pairs. If I have x and y, if I let x equals 0 and I insert that into the equation, this is going to be 0, f of x, or y, is going to equal negative 3. 1 then is going to give me a value of f of x or y of negative 1. And then I could use 4 and generate a second point of 5. So I have some coordinate pairs, 0, negative 3, 1, negative 1, and 4, 5. So now I can go ahead and graph these out. 0, x is 0, y is negative 3 is my first point. X is 1, y is 1. So 0, negative 3, and then I have 1, negative 1, and then finally 4, 5. And I could connect this out to form my line. Mistake. Correction on this point. X is 1, y is -1. That point should be right there. So now I'm going to go ahead and connect these and find that I have a straight line. So this is a linear equation. And I solved this I was able to graph this by generating some sets of coordinate pairs. In our first example, we're going to determine whether each equation is linear. Okay, this first equation I have is A, for letter A, is -2/3 x minus 3/4 y equals 9. Remember the definition of a linear equation. A linear equation can be written in standard form, and standard form is ax plus by equals c. I'm looking over here, and it is in that form. A is -2/3, B is -3/4, and C is 9. So this is in standard form, so this is a linear equation. I'm able to put it, or it's already in standard form, so it's a linear equation. Now, I look at this second one, and I compare it with my standard form. 3x minus xy plus 2y equals 7. Well, I look, I have my A is 3, and I've got a B over here of 2, and I have a C, which is 7. But the thing is, I have this minus xy term in the middle, and there's no way to get rid of that. Therefore, with that there, with the negative xy, it is not in standard form. I can't get it into that form. So this is not a linear equation. And then I have my third one. And with this third one, I wanted to try to put it into this form, because if I can get it into standard form, then I can determine if it's a linear equation. The first thing I need to do is to get this y out of the denominator. In order to do that, I'm going to multiply both sides by y. And what that's going to give me is 7xy equals 9y minus 4. Great. Now, I got this out of, I got rid of the y in the denominator. And to make this look more like this, I'm going to go ahead and subtract 9y from both sides. So I'm going to have 7xy minus 9y equals -4. Well, I compare it. And this first term does not match standard form. There's no way to make it match standard form. So therefore, this third one is not a linear equation. So the answers were that A is a linear equation. The other two could not be put into standard form. Therefore, those are not linear equations. This second example also asked me to determine if the following is a linear equation. Again, I'm thinking about standard form, ax plus by equals c. And it actually is possible to manipulate this equation algebraically to get it into standard form. But there's another problem with this one. If I look, I have 2 divided by x minus 3 divided by y equals 0. If I were to make x equal 0, I would end up with a term that is undefined. So I would not be able to determine what y is. So anytime x would be equal to 0, I wouldn't be able to determine a value for y. If I were to let y equal 0, I'd run into the same problem trying to determine my values for x. Therefore, you can't do this and end up with coordinate pairs for those points. Because of that, this is actually not a linear equation. Even though I could manipulate this around and get it into standard form, I've got a problem here with having x and y in the denominators. Find the intercepts of the equation x over 4 minus y over 5 equals 1. Okay, rewriting this, x over 4 minus y over 5 equals 1. Remember that for the x-intercept, I'm going to let y equal 0. At the x-intercept, the value for y is going to be 0. So if I go back here and I let y equal 0, I'm going to have x over 4 minus 0 divided by 5 equals 1. So x over 4, and this is going to be minus 0 equals 1, or x equals 1, multiplying x over 4 equals 1. So to move this 4 out of the denominator, I just multiply both sides times 4, and I get x equals 4. So this is the x-intercept. So the x-intercept is 4. Now, for the y-intercept, I'm going to let x equal 0. So I'm going to do the same thing, except this time, I'm going to let x equal 0. So going back to this equation, x over 4, let's let x equal 0, minus y over 5 equals 1. That's going to give me 0 minus y over 5 equals 1, or minus y over 5 equals 1, negative y over 5 equals 1. Multiply both sides by negative 5 to isolate the y, and I come up with y equals negative 5. So this is the y-intercept. This graph is going to intersect with the x-axis at x equals 4, and it's going to intersect with the y-axis at y equals negative 5. And I solved this by substituting, letting y equal 0 to find the x-intercept, and letting x equal 0 to find the y-intercept. Graph the equation using x and y intercepts. So we just discussed how to find x and y intercepts, and now we're going to apply that in order to graph this equation. First, I'm going to find the x-intercept, and I'm going to let y equal 0. My equation is 6x minus 8y equals 48. So my y value will be 0, and that's going to give me 6x minus 0 equals 48. So my y term dropped out, and I have 6x equals 48. Isolate the variable x by dividing both sides by 6, and I get x equals 8. So x equals 8 is my x-intercept. Now, the coordinate pair for that is going to be that x equals 8 and y equals 0. So at this point, x equals 8 and y equals 0. That's the x-intercept. Next, I'm going to find the y-intercept by letting x equal 0. I'm going to go back to that original equation, and I'm going to take 6 times 0 minus 8y equals 48. This gives me 6 times 0 is 0, so my x drops out, and I get negative minus 8y equals 48. To isolate the y, I divide both sides by negative 8, giving me y equals negative 6. So that is my y-intercept. Okay, so that means that my y-intercept is going to be down here at negative 6. So my x-intercept is here, my y-intercept is here, and now that I've got 2 points, I can graph this line. So remember, the value for the x-intercept is x is 8, y is 0. The value for the y-intercept is that y is 0 and x is negative 6. So they asked me to graph this equation using x and y-intercepts. I first found the x-intercept by letting y equal 0, substituting 0 for y in the equation, and determining that the x-intercept is 8. I then plotted that on the graph at the point 8, 0. For the y-intercept, I let x equal 0, substituted 0 in the original equation for x, and determine that y equals -6. So my second point is at 0, -6, and I can connect those 2 points with a line. So today we worked with linear equations, including the standard form of the equation and determining if an equation is in fact linear. And finally, we use the x and y intercepts to graph some points. Thanks for visiting educator.com.